Hello, Michael. First and foremost, thank you for joining us. So, you're going to be talking to us a little bit today about power quality. And we do greatly appreciate you sharing your time with us to do that. But before we dive into the topic at hand, do go ahead and give our audience a little bit of an introduction to yourself. Tell us a little bit about who you are and your professional experience.
Yeah, thanks, David. Glad to be here today. Mike Lyda with Advanced Energy. We're a small engineering consulting firm in Raleigh, North Carolina. Me personally, electrical engineer by trade, um, professional engineer license in the state of North Carolina, technical supervisor here at Advanced Energy, overseeing our commercial and industrial team and motors and drives laboratory. Our official total team title is large business and industry. And we've been foraying into the power quality field for the last few years and looking for ways to help out those large business and industry customers address power quality issues in their facilities.
Fantastic, very good. So now, of course, to the topic at hand, let's actually talk about power quality. So I think to most of the audience, the concept is probably familiar if they're watching this. But nonetheless, there might be some who are not familiar or who need a brief review. So do start off by just answering the very simple question for us. What is power quality?
Yeah, good question. And you're right, kind of maybe simple to some folks. I will start with a basic definition. So, kind of how we define power quality here is any change in the electrical power, um, voltage, current, frequency, any change in one of those three um, parameters that impacts the normal operation of a piece of electrical equipment. Now, in a facility, that may be, you know, a boiler, a chiller, a motor within that piece of equipment, a motor that's feeding an air compressor, so things like that. In your house, it may be your lights. You see a little blink of the lights, or you see the power, not maybe even longer than a blink, a temporary power outage or something. These are all power quality events. Um, a few more examples of power quality events. The most basic one is the full-on power outage. So we're here in Raleigh, North Carolina. Major utility in our state is Duke Energy. So you'll hear me list off some definitions or time frames definitions around various power quality events. Those are coming from Duke Energy defined definitions. Duke Energy is also a utility member of Advanced Energy. So the way Duke Energy defines power outage is, complete loss of power. But if that's longer than 1 minute, that's a power outage. Momentary outage would be short loss of power. So in between kind of a few milliseconds up to 3 seconds. Temporary outage is where you get in between that 3 seconds and 1 minute time frame. So, even within just power outages, you have a couple of different definitions: a full-on power outage, temporary outage, momentary outage. But all of them are going to have impact on you and the facility, or they're going to have impact on you even at your house. This is an issue that affects everyone: residential, commercial, and industrial. A few other basic kind of power quality events: electrical noise. That's something that maybe was more common at your house when you had vacuum tube TVs. You go to a channel and somebody starts running the vacuum cleaner at your house. You start seeing the noise on the TV. That's also an issue that can impact in the facility. You know, you're not seeing it on the TV, but you're seeing it in the electrical signals coming from your PLCs out to the variable frequency drive that it's providing a control signal to, or soft starter or something like that. So electrical noise, and then voltage sag, voltage swell. These are two transient voltage events where your voltage is either increasing for a voltage swell or decreasing for a voltage sag for kind of short term, less than a second or so, very short period of time. Transient voltage event, a surge in voltage, we commonly associate that with like a lightning strike. That's where your voltage is increasing, by thousands of volts. It depends on what the base voltage is. But if you're on a low voltage system, 600 or 1,000 volts or less, you may see a surge that, the voltage shoots up a lot very quickly. That's more of a voltage surge. And then the last kind of events that we'll cover are a little bit more of a long-term issue, like over voltage, under voltage, or voltage imbalance. So with over voltage, if you say you're in a low voltage facility operating under distribution voltage, you have 480 volt coming into a facility, but consistently you're seeing 500 volts. That's not likely going to be good for your equipment, especially if it's sensitive digital electronics equipment. If it's seeing that high, I mean, they wouldn't always be seeing that high AC voltage, but some equipments like motors and more resilient three-phase equipment, it may not be as big of a deal, but that's kind of the definition for over voltage. Under voltage, if you're supposed to see 480, you're consistently seeing 440, 430, something like that. And then voltage imbalance is with a three-phase in three-phase voltage. Then you see maybe one of the legs at 460, one of the legs at 440, one of the legs at 470. Okay, so coming in to your equipment, if there's voltage imbalance, that's going to lead to current imbalance, and then current imbalance leads to excess heating of the equipment, especially in something like a motor. We have the motor windings. Excessive voltage imbalance leads to current imbalance, leads to hot spots. So those are some of the kind of basic power quality issues that you may see in a facility.
So you do a very good job breaking power quality into the different categories of disturbances we might see in power quality, which is very useful. And I also like that you give these non-industrial examples in some cases, because it shows us that even if we've never set foot inside a manufacturing facility, we're all sort of familiar with power quality disturbances, and we already know more about them than we think, perhaps, even if we're not engineers. So I like, in particular, the TV example, but you did give, I think, some manufacturing specific examples in the process of delineating the different types of power quality disturbances we might see. I wonder if there are any other specific means by which power quality impacts manufacturing that you might want to discuss as well, or do you think you've covered all the bases?
Yeah, that's a good question. In manufacturing specifically, power quality issues. So you may have uh, a sensitive piece of equipment that you really need to have the power quality, voltage, frequency coming into that equipment really needs to be super steady. And if you have, some transient voltage events going on down on the incoming power, they're going to fall under this momentary outage definition, if not even less than that. Not even a few seconds. You may be seeing power blips, voltage sags on the line of a couple milliseconds, 10 milliseconds, 20 milliseconds. Those in our house, that's not really a big deal. And if you have power going straight into a three-phase motor, very resilient motors driving a pump, motors driving a fan, voltage sags of 10, 20 milliseconds, not typically a big deal. But then you have a sensitive piece of equipment where you have some type of protection on that device. And if the control voltage of that device sees 10, 20 millisecond voltage sag at 40 or 50%, it's going to say something's wrong, and it's going to tell the main piece of equipment to trip off. Well, then if this is in the manufacturing environment, and say you're manufacturing semiconductors, or you're manufacturing any type of thing where your margins are very tight, your tolerances are very tight, your equipment's going to trip off. A CNC machine is another good example. Then equipment's going to trip off, or even if it doesn't trip off, you might not meet the manufacturing specs. tolerance specs that are expected out of that process or out of that machine. So what does that do? Downtime, you're not meeting the production, production slows, production stalls, downtime of the equipment, um, and those finished products just aren't what they're supposed to be. I can give you a specific example. I was in a wood manufacturing plant just recently, just last week actually, and they have very sensitive CNC machine. They're making these furniture pieces that are very intricate details. Been in business for many many years, and they have very nice automated process that they've come up with. And if they see a voltage sag on the line, then it causes the CNC machine to trip off. From the utility side, the power may be on 99.99% of the year. Maybe you're not seeing power for couple minutes a year if you add up all the voltage sags. But the machine will, you know, for the folks, the operators who are running the machine, they've loaded their piece of wood into the machine. It's in the middle of doing one of these very intricate cuts, and then the machine trips off right in the middle of that cut. Now that cut or that sanding, drilling is you got to pull that piece off of the CNC machine, move on to the next piece. So you spend a lot of time, operator time, machine time, energy, electricity, and you got to hit reset. So that's one example. I can give another example. We were in a pharmaceutical plant. This was a couple years ago, and they were making wasn't vaccine, but kind of vaccine related, and they were having some power quality issues that were impacting the um, HVAC supply fans that were keeping positive pressure in their clean rooms. And when the clean room would go into negative pressure, you'd have a sensor that would go off and say, "All right, something happened on negative pressure." You can't have um, negative pressure in a clean room because then uh, particles in the air may get into the equipment that you're making, and that equipment for this facility was something that folks would be, using in ingesting to their body. So the particles get in. Everything that had been made up to that point is can't be used. So then they will have to trash all of that production and then sanitize the clean room before they can start manufacturing again. So voltage sags were leading to that issue. They had variable frequency drives on the supply fans, but the control power coming into those variable frequency drives was coming from 480 volt AC transformed 4-to-1 down to 120. So when there was a voltage sag on the input power, they would see voltage sag not only on that three phase, but also on the single phase control power, causing the drives to trip off. Drives or trip off, then the motors aren't spinning, fans aren't spinning, supply fans aren't spinning. Then guess what? You lose pressure in the clean room. So it's an issue, kind of an issue that at the root cause, it wasn't that hard of a fix for them. They installed some equipment, and maybe we'll get into some of that, into some of the equipment that they used. But coming to that conclusion, it takes some time to get to that conclusion, and it was costing them 6-7 figures over a year because of this issue.
I see. So because the requirements for manufacturing are so stringent and so tight, even a small disturbance in power quality can have large results that cascade that would not be the case outside of a manufacturing setting. So it becomes it seems that much more important. So on that note, and I think you alluded to this, do give me a little bit more information about how these issues can be mitigated.
Yeah, that's a good question. So there's different equipments that you can install to help mitigate power quality issues. I will just give a disclaimer that Advanced Energy is not a product manufacturer, nor do we endorse products. So I'm not mentioning products for any reason other than, hey, this may be a good fit for your solution. And I'm not going to mention any manufacturer names, or product names, or just types of products. So the first thing, and this was the equipment that came up for the pharmaceutical plant, uninterruptible power supplies. So UPS, not the big brown truck guys, but UPSs that can be used to isolate power coming into a facility. Uh, you put power into the UPS, and then you have output power from the UPS, which is basically like a battery bank, simplified definition. Output of the UPS into whatever load that it's serving. So you can have UPSs that serve only control voltage, so very small, 1,000 volt amp, 1,500 volt amp, or you can have very large UPSs that serve whole facilities. Those aren't going to be very common. You might find those in places like air traffic control centers where you absolutely can't go without power. Um, so that's one thing, and that was a solution, one of the solutions we found for the pharmaceutical plant. Um, whole facility UPSs, though, I mean, you're getting pretty expensive. That the prices are getting up there. Small ones, not so bad. Constant voltage transformers is another one. These are typically smaller solutions. Again, you're just serving the same purpose as UPS. Typically, it can be a cheaper solution, but you're isolating input power from the output power. So passing input power from the grid into a constant voltage transformer, having an isolation in between, and then having output power from that CVT out to whatever load that it's serving. Um, they're not going to be as robust, or they're not going to serve you long term like a UPS would. CVTs, they're different brands and they're different types, but they're going to give you ride through for a couple of seconds. UPS, it may give you ride through once it deals with that initial voltage sag or transient voltage event. It may be able to serve you for 45 minutes or an hour. The constant voltage transformer is more of a short duration solution. A few other types or things that come to mind: phase monitors. It's a very common one. This is nice cheaper option for you to help protect your three-phase equipment. Phase monitors monitor the incoming voltage, and they typically have some dials on them. Like you can set for over voltage, under voltage. So say you have 480 coming into a piece of equipment, a chiller that has various fan, pump motors, fan motors, then you may be able to put this on the incoming power to protect all of those devices. And if you can set it like 5% over voltage and 5% under voltage, and then 2%, 3%, or 3% voltage imbalance. You set the dials, and then if that phase monitor, it's in parallel with the motor or the equipment that it's serving. If that phase monitor sees anything outside of the range that you've set the dials to, then it will trip off. And so, it might be a normally open, normally closed contactor inside the monitor. Then you just have fed, when you did the initial wiring of the phase monitor, you feed the contactor circuit of the phase monitor over to a three-phase contactor, and then that's in series with the motor, and then that trips the contactor, which sets the motor off, open circuits the motor, so it can't continue seeing that poor power quality coming in, over voltage, under voltage, voltage imbalance, whatever the case is. And those will be in series, or excuse me, the phase monitor would be wired in parallel with your motor control center. So you may already have something, soft starters, variable frequency drive, or maybe you just have grid power coming through a three-phase contactor that's serving a motor. Similar to the phase monitors, you can have overload relays for voltage, or excuse me, phase monitors for voltage. Overload relays would monitor current. So it's just like if you have current at a certain amount going into a device. You can install an overload relay. If it senses that current going any higher, it will open the circuit to that device, similar to overload relay wired into a three-phase contactor. When that contacts opens, contactor would open the circuit. One other device, and there's hundreds. We could spend hours going through this question.
Yeah.
One other one that I'll mention because it's very common, and this is a power quality issue, is capacitor banks. So in various facilities, you may have high levels of reactive power. If it's a facility that has a lot of motor loads, your utility may charge you for having a low power factor. In most of the utilities in North Carolina, they're looking at 0.8 or 0.85 power factor. You get below that, and they reserve the right to charge you excess for having to supply higher power to you than basically what the real power draw is. The way power factor works is in your facility or in a facility, you have real power that's used. Then you have another number that's called apparent power. That's the amount of power that needs to be supplied to the facility from the utility or the generator to serve that real power to be used. A piece of equipment like a motor, it needs reactive power, which is kind of like the difference between real power and apparent power. It needs reactive power in order to operate because it's an induction motor. So because it needs that, but then the utility, they're having to generate more power than what you're using, but they only charge you for the real power used. So if you start getting to that ratio of real power to apparent power starts getting to be too much, then again, the utility reserves the right to charge you for that. If that's the case in a facility, you may need to install something like a capacitor bank. Capacitors offset the inductive loads like electric motors. So at near the utility meter or near a specifically highly inductive piece of equipment, you can install capacitor banks. What that's going to do is bring your power factor closer to 1.0 or unity. So it's going to give you power factor correction. It's going to reduce your reactive power. And also, if you have low power factor from heavily inductive loads, you may see within your facility some low voltage, right? So adding capacitance may raise your voltage up a little bit too, if that's becoming a problem in your facility. So those are a few items that you can install to help deal with some power quality issues.
And that's extremely helpful, and I very much do like the problem solution format. You give us a problem, and then you give us a means by which it's solved. And I hope for our audience, maybe there's even something they recognize that they can cling on to and recognize that they've struggled with in their own facilities. I do have just one final question for you before we conclude, and that is, who should an end user contact when a power quality issue emerges?
Yeah, that's a good question. I think you should start with the electric utility. So, they're there to serve you in industrial sites, commercial buildings. Depending on the utility, you may have an account manager, and depending on the size of your site, you may have an account manager. That's the person to reach out to first. If you're a homeowner and you're experiencing some power quality issue, just reach out to the utility on their contact us page, support line. And that's kind of the cliche answer, but that's where I would
Yeah,
start. And
yeah,
for large industrial sites, you know, they're for large industrial customers, a utility is typically going to have, a team of power quality engineers or technical folks to address. And it's very likely when an issue comes up, you may not be the first person who encountered that issue. So hopefully you get the experienced power quality team and they can come out look at your issue. They may bring some meters. They may do some interviews and do an investigation, power quality investigation of what's going on. They may bring some meters. It's not always going to be solved that day. That's something to definitely to understand. These capturing these events that happen only a few times a year, you may need to set up a meter, let it record until the event happens, then come out and get that data. So definitely start with the utility. The utility may, if the utility can't come up with the issue, some utilities also don't like to go on the other side of the meter inside the facility. So if you've went through the utility, haven't gotten the solution, or utility may come back and say, that's within the facility, that you can come to a consultant like me, like Advanced Energy. We'll be happy to come in and track it down for you. We work with the utilities very closely on these types of things. And we'll also come in with kind of an unbiased third-party approach to figure out what's going on and hopefully help solve the problem.
Absolutely. So, Michael, you've provided us with a lot of great information. Unless you have anything else you'd like to add before we conclude, I think we can go ahead and draw this down.
Thanks, David.
Yeah. Okay. Yes. Thank you very much, and thank you also to our audience for tuning in.